Good morning everyone, this is Shravani and welcome to Nrcm. I am going to speak about operating system subject of Unit 4 and topics are like memory management. So first of all, coming to the memory management. So as we all know that memory is very important component in a computer because both the operating system and the various user applications they have to be loaded into the memory. Yes or no? So first of all, if you want to save or if you want to execute the program, so everything, the file should be saved into the memory, and if you want to execute the program, the executable program, which should be loaded from secondary memory to the main memory, and then the execution will be happening. You all know this, and so the efficiency of memory management is too much, and it extends the effects and the efficiency of the whole system. So as you can see here, so here it is the like memory, like what happens inside the memory. Like here operating system is there and these are the processes. The processors are nothing but those are the programs, different programs if you want to execute the program. So this can be, I just want to show. So this is the program 1, consider this is program 1 or process 1, or this is process 2, program 2, or this is process 3. But sometimes it might happen like one single program will be divided into 3 different processes also. Okay, and as you see the diagram here, so here we are having, as you all know, the topic what is operating system, and we understood what is process. And so as you see here, what is the base? So this is the base is nothing but it is the register. So and this register holds a base address and the addressing field of the instruction. So okay, and next coming to this is limit register. So this is also one kind of register. As we all know, the register is used for storing some value, and limit register, it specifies the size of the range. Okay, what should be the limit? Okay, it will be having starting and ending limit. So here a pair of base and limit registers, this specifies the logical address space, and here the base and the limit registers can be loaded only by the operating system. So we cannot do it by our own. So if the base register, suppose I just wanted to show the example, the base register it holds like 30040. I mean this is the base address register holds, this is the value, and consider the limit register is holding like 120900. Then the program can legally access all the address from 30040 to like 420939. So in between this, so it can access, the program can legally access all the addresses. So within that, so I hope you are understood. And here there are some binding of instructions in data to the memory as well, which indicates the address binding of the instructions and the data to the memory address can happen at 3 different stages. So first stage is known as compile time. So at compile time, this binding instruction will happen. So what happens, like if the memory location is known, or if the memory location is known, then the absolute code can be generated. But the recompiled code, its starting location changes. That is, in the simple words, if you recompile the code, and then the location will changes. Okay, so once we compile the program, the memory address will be different, and if you recompile the program again, so that will be changing. Okay. Starting location will be changing. Second is load time. So the load time is, it will generate relocatable code. Okay, the memory location is not known at the compile. So the memory location is, it is unavailable or it is not identifiable. So then during the load time, then relocatable code will be generated. Okay, next is execution time. Execution time is like, it is like here if binding is delayed until runtime. The process can be moved during its execution from one memory segment to another. So it needs hardware support for address maps. So during the execution time, these base registers and limit registers are useful for us. So to searching, so where the file is present, so this will help us to search the file very easily. Okay, I hope you all understood. And next, moving on to the next slide, like we understanding what is logical address, like what is physical address. So generally, logical address is generated by the CPU while the program is running. The logical address is nothing but it is also called as the virtual address, as it does not exist physically. So therefore, it is also known as virtual address. This address is used as a reference to access the physical memory location by the CPU. So as the name itself indicates, the term logical address space, it is used for the set of all logical addresses which are generated by the programs specified. Okay, here the hardware device, which is called as memory management unit, it is used for mapping the logical address to its corresponding physical address. Now, understand what is physical address. So here the physical address, it identifies a physical location of required data in memory. The user never directly deals with the physical address, but it can access its corresponding logical address. The program can be accessed by its corresponding logical address. Here the user program generates the logical address and thinks that the program is running in its logical address, but the program needs physical memory for its execution. Therefore, the logical address must be mapped to the physical address by memory management unit before they are used. So the term physical address space is used for the physical address corresponding to the logical address in the logical address space. I hope you all understood. And now coming to the difference, like the main difference is the logical address. It is generated by the CPU. As I discussed, it is also referred to as virtual address, and physical address is seen by the memory unit. So here what happens, the basic difference between, and this is the basic difference between. Okay, then logical, the second is like you can see like logical address space. It is a set of all logical addresses which are generated by the CPU for a program where a set of all physical addresses mapped to corresponding logical address is called as physical address space. Okay, so next is the logical address. It does not exist physically in the memory, whereas but the physical address what it is a location in the memory that can be accessed physically. This is known as so this is known by all. And next is the it is like to identify logical address, like some identical logical addresses, they are generated with the compile time and load time. Okay, and the load time addresses binding methods whereas it differs from each other in runtime. Next, you can see like the logical address is when it is generated by the CPU, the program is running. Okay, and whereas the physical address is computed by the memory management unit. Like wherever we store the file, so that will be the physical address of the file. Like logical address is because why it is generated by the CPU while program is running is, as you all know that the program has to be like, first of all initially the program will be stored in the secondary memory, because as memory is very crucial, so it will be stored in the secondary memory. So whenever you use the program, whenever you run the program, so then what happens, operating system will, whenever you execute the program or any of the file, so then it will take it from the secondary memory and it places in the main memory. So then this time the process will be created. Okay, this time the process will be created. So it will execute, it will use the memory, the program will use the memory to bypass like normally it is program is executing. Once completion of the execution, then what happens? Then it will be moving from the once after finishing, then it will hand over all the resources to the operating system. So if the resources are getting used, means it will hand over to the operating system. So then again it will move back to the file or the program. It will be going and storing it in the secondary memory. This is all what happens. I hope you understood the basic about this logical and the physical address space. Thank you. We'll come with the next step.